Today we'll be doing problem A from the UTPC Contest Division 2 from CodeForces. In this problem, we're given n pigeons and m nests. Now, and we're trying to find if the pigeons dressed optimally, how many pigeons must there be in the fullest nest? Meaning we're trying to find the maximum number of pigeons that are in a nest. So, let's think about this, okay? Let's say we have... Okay, let me pull up paint real quick. Sorry, okay. Let's ignore the n. Let's ignore n and focus on m for now. So, let's say we have 3 nests. Okay, let's make these a bit nicer. Here, so we got our... Okay, sorry about this. So here's our 3 nests. And now, let's just make n variable. So let's just say n is equal to 1. As you see in this case, this nest would have the most with 1. Now let's just keep adding 1 until we see that all of them are equal. So the fullest nest would still be 1. However, once I go past that, it'll be 2. And just keep adding until all of them are full, and then if I add another one, it'll be 3. Now, what are we noticing? So first of all, the maximum nest is always going to be the 1. This nest would always have the same number as the maximum. So this means that until all these nests are full, the maximum won't increase. Okay, let's rephrase that. The maximum number of pigeons in a nest cannot increase until all of the nests have the same number of pigeons. Now, let's think about this. We're dividing the pigeons among nests. Keyword, dividing. So, we know division is probably going to be involved in some way. And so, let's look at this again. So, in this case, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. N would be 10. And as we know in Java, when you divide, it truncates. So 10 divided by 3 is equal to 3. Now, what this tells us is not the maximum number of pigeons, but rather how many pigeons are there, like in a nest, at minimum. Because you see, all these nests have 3 pigeons. However, we have 1 remaining. And you might think, well, that means we add it, but no. If we had 11, that pigeon would go here, and our answer would still be 4. This means that if n is not divisible by m, the maximum number of pigeons would be n divided by n plus 1. Okay, so let's go do look at the solution. So we first imported java.util so we can use our scanner. Then we put in n and m. The reason why we are using long is because n and m could be up to 10 to the power of 18, which does not fit within an integer. Hence, we had to use long as our answer as well. Next, we check if n is divisible by m by seeing... Well, we're checking if it's not divisible by m, seeing if n modulus m is greater than 0. If we do, we make our answer 1 just to accommodate for our... just account for the scenario where it's not divisible and we just have a situation like this, where multiple nests have 1 more than what is the minimum. And then we add n divided by m. Because we know at minimum there has to be at least n divided by m pigeons in each nest. And as you see, it was accepted. If you're confused by this, go ask in the Discord and I'll try to help out. Otherwise, there's the solution.